In the last lecture, we reviewed our understanding of charges. To easily understand different methods of charging, we can go back to our picture of the structure of atoms. Atoms are made up of three subatomic particles, namely electrons, protons, and neutrons. The first two particles, the electrons and protons, are negatively and positively charged particles. Neutrons, on the other hand, are neutral. The protons and neutrons are densely concentrated into a very small point in the atom, making up what we call the nucleus. We can as well remember that the number of protons determines the atomic number of the element. Therefore, we can say that the number of protons is the fingerprint of the material. The electron, on the other hand, surrounds the nucleus. In atomic scale, we can say that they are several kilometers away from the nucleus. Because of the distance that separates them, electrons can easily jump from one material to another. This makes the electrons charge carriers. For this lecture, we will talk about how to charge materials, or simply how to transfer electrons from one material to another. We have three methods: charging by friction, charging by conduction, and charging by induction. Some of you may be familiar with this already, but let us see if we have common understanding in these three methods of charging. Objects are usually electrically neutral or uncharged, but they may become electrically charged with one another when they are rubbed against another material. When one material is rubbed against another, of course, friction force will be present. This force makes the transfer of electrons from one material to another possible. The material that has gained electrons is now negatively charged, and the material that lost electrons is now positively charged. This is what happens in the previous example of two balloons rubbed on your hair. Both balloons become negatively charged. That is why they repel from each other. But I think the most important question for this method is how can we determine which material will become negatively charged and which will become positively charged. Both in chemistry and in physics, we have this term triboelectric series, or the electronegativity scale. This scale ranks materials based on their tendency to acquire or lose electrons. These materials are arranged based on their electron affinities. Have you encountered that term before? If so, which of the following can be the best definition of electron affinity? That is correct. Electron affinity is the property of a single unbound atom, and it quantifies the amount of energy released when an electron attaches to the atom. We can say that the higher the electron affinity of an object, the greater its tendency to attract electrons. In your screen is a sample triboelectric series. Let us use Teflon for example, which is found at the bottom of the series. It has the highest tendency to gain charge. That is why when you rub a cotton on this, Teflon becomes negatively charged, while cotton becomes positive. Pause this video or take a screenshot and write this on your paper, because we will be having a short activity after this. If you are ready, I will give you pairs of materials and identify what charge will be produced for each of the object. It seems that you mastered charging by friction easily. The next method we will talk about is charging by conduction, or also known as charging by contact. This occurs when a charged object is in contact with a neutral object. Let us illustrate this. Here, I have two objects. One is negatively charged and one is neutral. When we move the two objects closer with another, the protons and electrons will be aligned, in such a way that the positive protons will be attracted to the negatively charged material, while the negative charge will be repelled. At this point, no charge will be transferred since they are not in contact yet. Once the objects are in contact with each other, some of the negative charge from the negatively charged object will transfer to the uncharged object. When the process of charging by conduction is complete, the initially uncharged object now has an excess negative charge because of the transfer of electrons from charged particles. The charged object is still negatively charged, but it has less excess negative charge than before. I hope that it is clear. Aside from charging by friction and by conduction, which require the objects touching each other, an object can be charged if they are not in contact. This method of charging is called induction. To illustrate induction, let's say we have a ball on an isolating stand, which is a conductor because it allows the movement of the charges to take place. Then, we place near it a negatively charged rod. The presence of this negatively charged rod makes the positive charges to be induced in the side of the ball near the rod. The negative charged rod, on the other hand, tends to stay at the opposite side of the rod since negative charges tend to repel each other. When we connect a ground wire to the sphere, negative charges go directly to Earth, leaving the positive charges behind. As the ground is disconnected and the rod is removed, the sphere is left as positively charged, and that is how charging by induction occurs. In the next lecture, we will talk about the first physics law that explains the relationship of these charges. But that is all for this lecture. I am Gilmar Di Castro, and see you in the next video.